Okay, our goal on this example is to find the exact value of all 6 trigonometric functions of pi over 3, all right, using these side lengths. So what we've done is we've set this up that we are going to be focused on the left-hand side. You'll see that we have pi over 3 as this angle hanging out right here. So it's only that left graph that we're really focused on for this example. Now we've already set up sine, cosine, and tangent, basically using SohCahToa, right? SohCahToa to remind us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's go ahead and label our sides on this triangle. Because we're focused on that pi over 3, the opposite side is going to be the square root of 3 multiplied by s. All right, so that's opposite side. The s is going to be our adjacent side. And then the 2s is going to be the hypotenuse. So just kind of filling in, and these are ratios, recall. So when we have an s there, that s could be a 5, and then our hypotenuse would be 2 times 5 makes 10, and the adjacent side would just be 5, and then the opposite side would be square root of 3 multiplied by 5. All right, s is just going to be this nice scalar multiple that's going to be applied to all 3 of our side lengths. So as we get setting this up, let's first go ahead and determine what is sine of pi over 3. Well, it's opposite, square root of 3 times s, divided by our hypotenuse, 2 times s. Now you're going to notice as we get going on these that we're going to do some simplifying down, that we have s over s. That'll reduce down, and we can say a little bit better answer is going to be square root of 3 divided by 2. All right, no need to rationalize. Our radical's up in the numerator, so that's a great answer. All right, next up, let's try to do cosine, and then we'll do tangent, and then we'll talk about the other 3 trigonometric ratios. Okay, so cosine is going to be adjacent, so in our case, s, divided by our hypotenuse, 2s, and again, we get some simplifying down where we have s in the numerator, s in the denominator. As we simplify that down, that's going to make 1 over 2. Remember, when you cross out a common factor between numerator and denominator, you put a 1 in that spot. All right, finally, tangent is going to be opposite, square root of 3 times s, over the adjacent, just s. So again, s in the numerator, s in the denominator, a little reducing down, that makes a 1. So we're going to have square root of 3 divided by 1, which is really just square root of 3. All right, now that we've come up with these 3, the next 3, really how I like to deal with these is I don't set them up as secant is hypotenuse over adjacent and cosecant is hypotenuse over opposite and so on. Instead, how I like to think about these is with their reciprocal relationships. That sine goes hand in hand with cosecant. All right, they're reciprocals of one another, meaning that we can say cosecant is 1 over sine of pi over 3 in this case. All right, so what that really means is if you already have a ratio, a fraction for sine, all you have to do is you have to flip it upside down. You have to take its reciprocal. So in our case, it's going to be 2 over the square root of 3. Now we can clean that up a little bit, right? We don't probably want to leave a radical in our denominator. We want to rationalize that denominator. So what we'll do is go ahead and multiply by square root of 3 over square root of 3. That's like multiplying by 1. And that'll give us 2 times the square root of 3 over, well, the square root of 9, which works out to be 3. And that's the best answer we can get to in that situation. All right, the next pair that I like putting together is cosine and secant. You'll notice for each of those, one starts with an s and one starts with a c. Right, for the original sine and cosecant, then cosine and secant, each pair gets one s and one c to begin. All right, so again, this is 1 over cosine. So we already have cosine as 1 over 2. We can flip that upside down and say 2 over 1, which will reduce down to be 2 for our secant of pi over 3. And the last pair that goes together is tangent and cotangent. Usually students pick this up pretty easily. What we're going to do in this case is think of this as the square root of 3 over 1, if it helps to visualize it as a fraction there. Then flip it upside down, use its reciprocal. So 1 over the square root of 3. Again, a little bit of reducing down to rationalize that denominator. We'll multiply by square root of 3 over square root of 3. So it's like multiplying by 1, But that's going to give us a final answer here of 1 times square root of 3 for our numerator is square root of 3. And then square root of 3 times square root of 3 in our denominator makes the square root of 9, which reduces down to be 3. So there we have all 6 trigonometric ratios for pi over 3. Hope this helps out. Get down these reciprocal relationships and definitely the SohCahToa to be able to identify sine, cosine, and tangent. So I hope this helps out. Good luck.